So today what we're going to be working on is a process called completing the square. And completing the square is very useful if we're wanting to turn a quadratic in standard form into vertex form. Why would we want to do that? Well, if we want to see where the vertexes move to. And so we're going to do something where we create an artificial perfect square trinomial. And this is basically what we're going to be doing, is we're going to be adding b over 2 squared. Why are we going to be doing that? Well, let's take a look. Now, if we remember, a perfect square trinomial is something that we can easily factor. And the idea is that it's a trinomial, 1, 2, 3 terms, and I have a perfect square on each end. So I have x squared, which is a perfect square. I need something that is a perfect square. And if I factor something that's a perfect square trinomial, that means it's going to reduce down to something like x plus something squared. So I want to know, what do I need to add that squares up perfectly, that when I FOIL this, so when I'm checking my work, when I say x plus that something, x plus that something, let's call that something, let's call it b. Let's take a look at what happens when I actually work out this FOIL. So I multiply first times first, outer times outer, inner times inner, and last times last, which is going to give me an x squared. Then we have right here a bx. So x times b, x times b. So I have another bx. And then when I multiply b times b, I have b squared. And so I can combine these two middle terms into an x squared plus 2 bx plus b squared. So assuming that this follows that general format, I have an x squared. This is going to be twice b. This is going to be b squared. So if I want to figure out what b is, what this thing is, I have to divide it in half. And so, okay, what's half of 12? If 12 is 2b, well, then that means b is 6. So I'm going to add 6 squared. So what am I going to add? I'm going to add 36. That's what's in my little box. Which means that if I were to perfect square trinomial that, what is 36? What's the square root of that? 6. There we go. So what am I adding to make this a perfect square trinomial? I'm going to add 36 because that's half of that squared, which allows me to very quickly and very effectively factor that down into the square root plus the square root. We don't need to figure out, well, 1 times 36, what factors of 36 make a sum of 12, because I know it's going to be the square root. So let's try that on another one. Now, knowing that this general rule, and this is how we figure it out, I know that if 6 is twice b, what's half of this 6? Well, half of the 6 is negative, I'm going to draw that in red, negative 3, because half of negative 6 is negative 3, and that's going to be how I factor this. But what do I need to add over here to allow me to do this? Well, I'm going to have to take that negative 3 and square it, which means that I've actually added 9. So if I were to factor that, again, if you haven't followed through with this yet, if I add 9, which is half of that squared, I could very quickly and very easily factor this. Because let's look, for example, what it would look like. X squared minus 6x plus 9. Well, what you would do is you'd say, okay, 1 times 9 is 9. It's a positive 9, which means we're summing up the factors of 9. 1 and 9, 3 and 3. Okay, well, 1 and 9 make 10, which is not a 6. 3 and 3 make 6. I'd use those. So I'd split 6x into 3 and 3. So I'd say x squared minus 3x plus 9. What we would then do is we'd factor out the GCFs, which is an x and a negative 3, which means that my x and my negative 3, let's see, x squared divided by x is x, negative 3x divided by x is negative 3. Same thing over here, negative 3x divided by negative 3 is x, 9 divided by negative 3 is negative 3. So I know my two factors are x minus 3 and x minus 3, or x minus 3 squared. So we've proven that if I add 9, it factors down into this. Awesome. So what I want you guys to try is I want you to try this one. So go ahead, pause the video, see what you would need to add in order to be able to factor this in one step. Resume the video when you're done. Okay. Now this one's a little tricky because this one's an odd number. I know that in order to do that, I'm going to say, okay, if that is twice my b, then I need to divide that by 2. So I know that in this case, my b is equal to 9 over 2. Okay? Well, my last term is b squared, so what is 9 over 2 squared? Well, let's see, 9 squared is 81, 2 squared is 4. So I'm going to add 81 over 4. Awesome. And so I know if I add 81 over 4, I can factor that down to x plus that. So no math necessary. Actually, we've already done the math, so it's going to be x plus, remember our b of 9 halves? 9 halves squared. We don't need to factor it. We don't need to prove that we can factor it. We just say, hey, I know that if 9 is twice my b, half of 9 is 9 halves. Let's square it, 81 fourths, so therefore I can factor this in one step. Perfect. And so we can do that with literally any quadratic if we want to convert it into vertex form. Again, the skill that we're trying to do here is we're trying to say, okay, I can't do it right now because I see the fact that I have a 2. So one of the ways to get rid of that so I have a perfect square is I'm going to divide out a 2. And I'm going to say, okay, x squared plus 4x plus whatever this square divided by 2 is. So I have new square. In this case, my b, half of 4 is 2. 2 squared is 4. So my b is 2. So what I know I'm allowed to do is I'm allowed to say x plus 2 squared. There we go. Now, so what did we actually add? Well, if my b is 2, that's a 4. Distribute that back in, I get 8. There we go. So now that we've kind of seen it in action a few times, let's go ahead and let's give it a shot with an actual equation. And so this is an equation in standard form, and we want to put it in vertex form using the scale that we just learned. So what we're going to do is we're going to say, okay, what does my b need to be in order to factor this? Well, if 10 is twice that, my b is 5. So what is 5 squared? Well, we're going to add 25. Well, I can't necessarily just do that with an equation. If I add 25, I have to take away 25 because now this is balanced. But what it does allow me to do is it does allow me to factor this part. And so what we get is we said, okay, if b is 5, this is an x plus 5 squared. Where does the minus 25 go? It just stays out here on the right. And that's it. We know our vertex is found at, just to prove a point, our vertex is at -5, -25. Just as a side note. Okay, so let's try one more. I want to convert this to vertex form, which means that needs to be a perfect square. What perfect square? Well, if 4 is twice that, that means my b is 2 again. So what I'm going to have to do is I'm going to have to add, well, what is 2 squared? 4. So I'm going to say x squared plus 4x. I'm going to add 4, which means I'm going to have to take away 4 as well, because remember, these, just like before, are going to cancel out. Let's not forget about plus 8. Plus 8 still exists. But again, what it allows us to quickly do is convert this to an x plus 2 squared. Condense this. 8 minus 4 is 4. Boom. And so just to prove our point, our vertex over here is at -2, 4, just to show off. Okay. So I want you to use everything that we've learned today on number 13. Turn that into a perfect square trinomial, factor it so we can find our vertex. Unpause the video when you're done. So let's see how we did. I know that if b is twice 16, b is, in this case, a -8. And I know for that to be true, I'm going to need to add 8 squared. So I'm going to add 8 squared, which is 64, and I'm also going to take it away. And let's not forget the minus 66. This allows me to say that's x minus 8 squared. And the next thing I'll do is I'll say, okay, that's 120, 130. And if we wanted to show off, our vertex here is at 8, -130. Done. And there we go.